Integration. Integrate of
Yeah. Now you. Now you change.
Integrate, not integrate.
So this cancel.
No.
Only one.
Yeah, only this cancel.
Integrate.
No, it's not this.
Power plus 1.
Oh, plus 1 divided by the power.
Yeah, right.
Isn't it
Just wasted 2 years. Just wasted 2 years.
No, you didn't. What are you talking about? That's a nice looking muscle.
That's every time I buy something from
And
Starbucks or something.
You don't think that's worth €2?
No, I'm just imitating him. That's what he does when I buy something.
Oh, I see.
But he buy all the different chips, all those crisps,
Yeah, so
all the
that-
unhealthy stuff.
all this.
As if this is healthy.
Yeah, so this is healthy. It probably has like 2 days worth of sugar in it.
I derived it, integrated.
Yeah, but also power.
Oh, shenanigans.
Shenanigans indeed. Right.
You
The
could
one who is the same.
We'll continue
I don't
now.
want. No, okay. Yeah.
Fuang, Yahya, we're going to continue now to the next lesson. So, if you can move back, Fuang, please, to your right.
No.
Please, Fuang, please. Please! Omar, you're awake. You were asleep for the first class, yes?
No.
No? A guy that came to do something, huh?
The washing machine.
Wash machine, you say?
That's what
At 9 o'clock in the morning?
9:50. But he said 9:50. What? He said that the problem is with the machine itself.
He said your clothes are too dirty for the machine, and it broke the machine, was it?
No, there is no water. But he told me that there is water, but the machine is not taking water.
So does that mean a new machine?
I don't know. Because the automatic
Huh?
company.
Says okay.
Substitution? Replacement.
Oh, so what the called?
Integration.
Oh, integration. Substitution is different than
Yes, it is.
integration.
They're not the same thing. They're quite different, actually. You don't integrate a football player.
I told you I'm a bad teacher.
Oh, you were good.
No. His English is good. He'll understand.
No.
Well, his English is not good, or he
No,
won't.
because I explained he can't understand.
No, I understood.
Maybe the student is just not smart enough. It's not the teacher. It's not the teacher's fault.
Yeah.
Teacher can only do so much, you know. All right, we'll continue now. So what we're looking at now is integration again, and we're looking at what's called rational functions. So, can you write this title down, and I'll explain the words in it. So, Fuang, what does integration mean?
The
The yo-yo. Anyone can give me another word for integration?
Opposite of differentiation.
Yeah, opposite of differentiation, so antiderivative. Yes, that too, yeah. Now, a rational function is a function like this. If you have an example like, a linear over a cubic, or something like a quadratic, over a linear, you know, an x power n dot 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 over an x power m dot dot dot. These are called rational functions. That's all I mean. So when you look at the worksheet for this lesson, you'll see that they're all rational functions. Let's scroll down. Can you see that, guys? Guys, can you see that? They're all rational functions. So this one, linear over quadratic. This one, linear over linear. Number 3, these are constants over linear, and number 4, constants over quadratics. Now, what's special about the questions in number 1, so let me zoom in. This is a quadratic and this is a linear, but they actually have a relationship here that maybe you can see. How is the top related to the bottom? What is the... Yeah, no, you're right. Can you see how the top is the derivative of the bottom? Now, when we have situations where the top is derivative of the bottom, or the top is a multiple of the derivative of the bottom, like for example, here it could have been minus 4x plus 3, that is acceptable, then the way to integrate is just what we learned in the last lesson. So, I'll give you an example here. Let's say I want to integrate 4x plus something now in a second. So let's say 4x plus 2 over x squared plus x. What's the derivative of x squared plus x?
2x plus 1.
Which is a multiple of the top, correct?
Yeah.
It's actually half the top. So for these problems, we do what we did in the last lesson. We use substitution. U equals x squared plus x. Du dx equals 2x plus 1. So dx equals du over 2x plus 1. So this becomes 4x plus 2 u du over 2x plus 1. These don't cancel. However, you could take the 2 out of this one here. Now, do you hear that sound? That is the sound of understanding. And now they cancel. Yeah. Yeah. So that's equal to 2 log u plus c. So finally that's 2 log x squared plus x plus c. Okay, so that is a good example for the people who are late because it's using the same method as the last class. So if you can, everybody can write this down, please. Okay. You got that? Yeah. Okay, let's have a look at the next one. So can you just write down, please, this one, which we'll do now.
Which one?
2a. Yeah?
Should be something.
No, I just want you to write it down, so I'll do it now. Can I start it, yeah?
Yeah.
Yeah, okay. So, just read the question to me, please.
6x plus 7
Yeah.
over 2x. What now? Minus 7. No.
I got run back. 6x minus 7 over...
2x minus 9.
Yeah. So, again, what do we let u equal to here? Yes, 2x minus 9. So that means du dx equals 2. So dx equals du over 2. So that can go in, and that can go in. So this becomes 6x minus 7 over u du over 2. But the problem here is with the x, we don't like x here. So we need to rearrange this as u plus 9 over 2 equals x.
Y plus 9.
I rearrange this to get x. Can you see? No?
Rearrange what, for example?
This.
Oh.
Now we can put that in for x. So this becomes 6 u plus 9 over 2 minus 7 over u du over 2. Yeah? Now, this is pretty ugly, I think you agree. So we want to try and clean this up. Yeah. Well, you know, it's actually not as... I judged it harshly. It's not as ugly as it looks, because I can cancel the 2 with the 6 to make 3, and then expand. So I get 3u plus 27 minus 7 over 2u du. So that is 3u plus 20 over 2u du, which is 3u over 2u plus 20 over 2u. Now what happens here with the 20 and the 2? It makes a 10. So this becomes, oh, and what happens here with the u's? Cancel. So this becomes 3 over 2u plus 10 over, 10 log u. I've integrated now. It's just a constant 3 over 2.
Yeah.
So that's 10 log u plus c. So finally, that's 3 over 2, 2x minus 9 plus 10 log 2x minus 9 plus c. Plus c.
3 over 2u plus tan ln u.
Correct. Yes?
The u is next to q over 2 is cancelled.
Yeah, but then I integrate. Integrate. Yes, integrate. You wrote this down, Yusuf? Juan? We're waiting on a couple of people. Lee, you looked at this? Yeah. Okay. Omar,
Yeah, continue.
you got it? I'm in no rush, I'm tired.
We're gonna do the physics after this?
No, I'm too tired too, I'm sorry, I need a break. I need to get like, I don't know, a bucket of coffee or something.
So we're gonna do it at 3.
No, 2, isn't it?
Yeah.
Look, don't sound so sad about it, okay? It's not going to kill you to do it at 2.
3 hours break.
So go off and do physics for 3 hours.
Go to the gym.
Yeah, I'll go to the gym, yeah. Do some weightlifting or squats or whatever it is you do at the gym.
Where can I meet you?
At my office. We said at 12, didn't we?
Yeah,
Yes. Do you all have presentations you're doing? Is anybody doing a physics topic that they need help with?
I know. Yeah, not really.
Not yet.
Not yet. That means you haven't started.
Yeah.
What's your topic, Andrew?
Waves.
Waves.
How can we apply waves?
Oh, applications, gotcha. Yusuf? Copy him?
No.
Most of us are sitting in the wall.
Electromagnetic.
Why is everybody picking waves?
Easy.
Speaking about
everyone is in waves.
States of matter? Nice. Omar? Yeah.
That's too much waves.
Why you confused?
So
Wave is easier.
Don't listen to those.
it's easier if you're better at English than physics.
Can we make a presentation about nuclear physics?
You can.
Yeah, but it wasn't one of the topics.
I know. I just gave down as a list of topics. I really should be doing a topic that you've already studied in class. Now, there's no rule saying that you have to. I mean, it's not like it's written down in the syllabus somewhere saying, oh, it has to be a topic that they studied. But that's just kind of what we usually do. I think, if you want to do a presentation on a topic that you could study at university next year, then that's acceptable too. But I don't think you're doing nuclear physics next year, are you? No. So I don't know. Who's your tutor for this stuff? Could ask Emer. Do you want to change the topic?
They probably should ask him to
Yeah.
You should agree to the new topic.
It is a busy topic.
You want to do nuclear fusion and fission? It is an interesting topic, and I would like that. It would be a good idea. So if you want to tell Emer I'm happy with that as a topic, you can. I think it would be more interesting for the people grading you too, because could be like the 5th topic on waves or whatever. So I think if we could get a bit more variation here, it would be good. Yeah. You could do
I'm doing 2 presentations, and I'll pick one.
Okay. Are they both on waves?
No.
Okay. Right, let's go to the next one now. You got that, Omar? Yeah. Yep. Okay. I don't remember if I mean, I'm pretty sure I did do the proof of this. But maybe you don't remember. Does anyone remember what this equals? We did it in the lesson on implicit derivatives. No, you don't, okay.
Oh, it's the x minus 1 over x minus 1. Or 1 minus x.
Not that one. Not that one. Not that one.
Half lower.
No. 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 Right. Let's have a look. Look. Let's say you have something like y equals tan inverse x. So this also means that tan y equals x. And do you remember the definition of tan? It's opposite over adjacent. Why am I saying 1 here? Why did I pick 1?
Because it has to be x, then tan y equals x. So tan...
It's over 1.
Thank you, Fuan. X is over 1 here. Yeah, that too. Yeah. So, we can use implicit derivatives here. Derivative of tan y is 1 over cos squared y dy dx. And derivative of x? 1. So dy dx equals cos squared y. And cos is adjacent over hypotenuse. Yeah? So that's equal to 1 over 1 plus x squared, the derivative. So that means the integration is back to y. So we end up with the result. And what did we say y was earlier? Y is tan inverse x. So we end up with this result. Integrate 1 over 1 plus x squared dx. That should equal tan inverse x plus c. So this is the result that you need. And this, I should tell you, in the exam you do get proofs, but usually only on trigonometry topics. This counts as a trigonometry topic because it uses the sine, cos, tan. I have seen this proof on the exam once before. So this is something that is possibly something you could be asked in the exam, is to prove this result. So this is like our first topic we've done in semester 2 maths that could be a proof on the exam. So here we're trying to, I guess, prove this. So this is the proof here. So please write this down carefully.
Is that cos squared y or cos xy?
Yeah, so it's cos squared y.
That's cos y, right? Yeah,
What are you talking about? They're all cos squared y's.
no.
Okay, do you have that proof yet? Is that a yes or a no? Who am I waiting on? 3 people.
Do we have to draw the triangle?
Yes. Okay, continue. Continue. Super duper. Let's try 3A. Can you write 3A down, please? Now, Lee, you were asking me earlier about the U.
Yeah.
This is an example when the U is not 4x squared plus 1. No, something else. Okay.
I got it.
You sure? Okay. What? No? Okay, what was the question, please?
16 on the square square
Plus
1 on 1.
1. Now here, Lee,
yeah.
U is not 4x squared plus 1. We use a different U here. We let U equal to, no, it's not linear. Listen carefully, this is a tricky one. You let U equal to the square root of the first one over the second one. In other words, you let U equal to 2x. Okay, so what does du dx equal? 2. So that means dx equals du over 2. You can put that in here, and you'll get 16 over u. No, you don't. What am I saying? 16 over 4x squared plus 1 du over 2. Now, we have to simplify. Watch this. If u equals 2x, then what does u squared equal?
4x squared.
So this becomes 16 over u squared, u squared plus 1 du over 2. The 2 and the 16 make 8. Now does this one look familiar? 1 over u squared plus 1. Yes. So what is that?
Inverse u.
Yeah.
Let's see.
Let's see. So now we have the answer. The answer is 8 tan inverse 2x plus c.
Why is it u squared and not u?
What?
So we need to get 4x squared.
Yeah. Okay, do you have that written down? No. What about now?
Explain again while done.
Explain integration. Which part, Fuang? Go up to the board and show me which part. That's true too.
This to this.
Earlier. Where'd it go? There. This is a new rule. So for example, this becomes this.
Oh, we accept that?
Yeah, it's a rule. It's in the book. It'll be in the book. I can see my battery's a bit low, but I think I've got enough to get one more example out.
Maybe if you use a green pen.
It's coming like that. Right, better plug it in, so. Gone critical. Where the heck's the power? Hang on, I'm just charging up the battery here. Oh, it's Samsung. Right. Can we do another example? Yeah.
Why isn't the U equal 4 squared plus 1 in this question?
Yeah, because it doesn't work to simplify, because if you use that you can.
Is this the way, like how can we different that from each question? Like which way should we use?
If you make u equal to 4x squared plus 1, this is a bit like what Wong was asking me earlier. The exam sometimes tells you what to use for the u. And it's not like if you use a different u, it's wrong. It's just the choice of the u can make the problem easier or harder, or stay the same. So I mean, there's nothing wrong. It's not like you're doing a wrong thing by making u equal to 4x squared plus 1.
It is like the same answer.
You will, but it's so much harder. In fact, it might even be harder than the original question. So the choice of the u is from experience, from knowing what will make it easier. And when you see problems like this, there's a number and a quadratic that usually means it's a tan inverse. Yeah, like the trick here, Omar, is u should equal the square root of the first one over the second one. This seems to work quite nicely here. Let's have a look at another example. Can you write down this one, please? Well, we'll go with B, actually. No. A. Okay, ready? Right. Integrate, what's on the top? Over. Well, the very first thing we can do is divide everything by 4. Not that that helps too much, but still, every little helps, like they say in Tesco. Right. Now we have a problem here.
Can you do that? It's not an equation.
Yeah, but as long as you do the top and the bottom of the fraction, it's acceptable. Right, now we have a bit of a problem here, because the trick we have is let u equal to the root of the first one over the second one, but we kind of have 3 terms here. So what could we do? Any bright? You're going for x squared over minus 2x over 2?
Yes.
No.
Just u equals x squared minus 2x plus 2.
No.
It's different.
No.
U equals 4.
Definitely no.
2 times,
What?
no, 2x.
No, you're all wrong. What you do, no, complete the square.
Okay.
Now, you have two terms. So you let u equal the square root of x minus 1 squared over 1. So u equals x minus 1. So du dx equals 1. So du equals dx. And by the way, what does u squared equal? X minus 1 squared. So, this now becomes integrate 4 over, what's x minus 1 squared? 1, 1. dx,
1.
du. Right? So this becomes 4 tan inverse u plus c. So the final answer is 4 tan inverse u, which is x minus 1 plus c. Cool. Yep. This would be a hard one, but even this I don't feel is too outrageously hard. Is it okay, guys? Right. Let's see. Yeah. So, Omar had a very good question, and I think Lee was kind of asking it earlier as well. How do you know what the u is? And there is no secret answer, but just to recap what we've learned today, when we have two functions, one possibility is to let u equal what's on the inside. So like, if you had ex squared, u would equal x squared. If you had a function over a function, so far we've learned you let u equal to gx, but, and then we have the exceptions that we learned. So for example, if you had a linear over a linear, that was okay, you let it equal to the bottom. And in fact, if you had a linear over a quadratic, that was okay as well. When do we need the special rule that we just learned? But for a constant over a quadratic, what do you let u equal to? Yeah, that's it. The square root of the first one, which would be something like a x plus b squared all over c. If this quadratic has been completed, like you said, completed square form like this. Yeah. So in your head, Omar, you're kind of building up a list of what to do in what situations. So we kind of have three situations of substitution today.
It could be one, right? This way.
No, it doesn't. It doesn't.
Has to be
Just the examples I did, conveniently they were one, but it doesn't have to be. It just has to be a C, a constant, no X in it. Okay guys, are we happy with that? Yeah. So we won't have the extra class now, I'm sorry, I'm way too tired, I need to take a break. I know it seems like I just started, but please remember I was trying to fix my server this morning and last night as well. In addition to all the other things you have to do when you move into an empty house, I tried to get the washing machine last night. I'll tell you, I ordered the washing machine, and he took the washing machine and he left it at the front door, and my wife said, "Oh, can you put it in the kitchen? This seems normal, right?" And he said to her, "No, I'm not insured to enter the house any further."
What?
So I got home yesterday and the washing machine was at the front door.
Was it under the mat?
No. So I had to move a 250 kilogram washing machine into the kitchen, and that was hard and that was painful and that took a while. Yeah. So the website I used to buy the washing machine, I'm like, "This is great, they're so cheap." And I'm like, now I understand. I'm not going to use them to get my fridge. Alright guys, I'll see you later.